Hey Ajay, can you hear me now?
Yes, I think we are live
Okay,
as well.
we are live also.
Yeah,
So, hi everyone, I'm Aditya Saladi and I have Ajay with me. Sorry for the delay, 7 minutes delay. Guinea was facing some issues with her laptop, so that's the reason for the delay. Okay, without any further delay, let me just quickly get started. Today is day 6 of Azure AI Cohort, and this is 8 week, 8 session series on Azure AI. And we have already completed 5 sessions, and you can find the recordings in the Azure Developer Community YouTube channel. But even if you haven't gone through all those recordings, feel free and watch this session with your open mind. We'll are going at level 100 or level 101, so you will be able to easily follow whatever we are speaking, right? Let me just give a quick recap of what happened in the last few sessions. In the first session, we discussed about what AI is and what kind of applications are using AI, right? What is AI going forward, right? And then we discussed about how to use a simple sklearn library, and using pandas we just created one supervised learning and unsupervised learning algorithms, and I've showed a demo on that. And after that, we introduced you to a concept of data cleaning and pre-processing. In that, we took our data set, and on that day, we were discussing about the Titanic's data set, and we have showed you how to clean the data, how to analyze the data, and we gave a lot of examples on that. And after that, we went to deep learning. So we discussed a lot on deep learning also in session 4. In yesterday, which is session 5, we discussed about NLP. So we also gave a simple, quick demonstration on how to analyze the documents from the news articles. So you can just go and watch the recordings. And today is a continuous session. So let's get started. So before we start, let me introduce myself. I'm Aditya Saladi. I'm a software engineer too at Microsoft. Been here from last 5 years. Before joining Microsoft, I worked in Germany for my internship, and after that, worked in a couple of startups in India. And other than work, I am very active in all these tech communities, and I'm a big foodie, and also I've traveled 11 countries so far, and all of that journey I usually post it in my Instagram channel, which is code.with.wadi adi, and I also have a YouTube channel with the same name. If you are interested in Telugu tech content, please do subscribe my YouTube channel. So yeah, that's mostly about me. Now I'll hand over it to Ajay.
sure. Thank you, Aditya. Hey everyone, I'm Ajay. So I'm a principal software engineer with Microsoft right now. So I started my career in Wipro Technologies around 2010. So it's been more than 16 years in the industry right now. I've worked with big tech companies like Goldman Sachs, JP Morgan Chase, Oracle Cloud in the past. I started my contribution to the developer community in 2017. That's when I created a YouTube channel called Tech Primers, primarily focusing on tech and hands-on videos. I became a community builder with AWS for 2 years in 2020, and then I joined Oracle Cloud, and then now I'm with Azure in the product group, right? So that's a big background about myself. Yeah, again, if you're interested in tech content, anything on system design architecture, do check out Tech Primers if you're interested. So with that, coming to the session on the Azure AI cohort, if you've followed our sessions, you know that these are the resources. If you have not, please head to github.com/tech handbook/Azure AI cohort. So whatever content we make, resources which we provide, all these are available in the GitHub repository. There are also discussions if, let's say, you guys want to talk to us offline, apart from the sessions and the chats here, to head out to the discussion section. Every day there are assignments and goodies. If, let's say, you have not submitted some of these assignments or goodies, do submit them, and we will select these folks, right? And then we will send these goodies from Microsoft. As a bonus from our end, whoever is consistent throughout these sessions and the assignments, we will be picking up top 2 people, and you will get dedicated 1 hour mentorship opportunity from each of us, right? So that's another bonus thing which we both are providing from our end. Right now, coming to the today's topic or the discussion, again, this is a complete hands-on discussion for today. It's a mini project on sentimental or sentiment analysis from a social media streaming data set, for example Twitter, or maybe a news channel, right? So I will talk about how we can start from the beginning, and then how we can get to implementation, how we can plan, and then finally deliver the product in a production way using Azure. So this is how the agenda goes like. We'll start with the objectives and the scope. So any project you start with, if let's say you are a beginner, if you are from college, this is how things happen in the industry. If you're starting off a project, there will be objectives and there will be scopes for any specific project start. There will be planning for each of these projects, and then we come up with tasks and milestones for these projects based on the planning and the tasks which we came out of that project planning and grooming. And then finally we start with the implementation, right? The whole planning, milestone, implementation sometimes goes through agile practice, so we do have small milestones created, and then we start the implementation then and there, and then we reiterate the whole process, right? So that's what we will see, like how we build a project from scratch, right? Now coming to an example of what we want to build as a part of this activity is we want to have some sentiment analysis based on the social media messages which are flowing through, right? Let's say for example, Twitter has been a very popular platform for people tweeting and then identifying sentiments of users specific to a geography or a particular during a particular period of time, or based on a particular event, right? For example, big movie launches, or maybe live streams, or maybe election events or political events, etc., etc., right? So we want to analyze Twitter's data set, and using that data set we can find out what is the mentality of people, which people are talking about a particular keyword, or maybe a specific sentiment of a particular event, right? Whether it is going the positive direction or a negative direction, right? So the reason why we picked up Twitter dataset is because Twitter streams or Twitter feeds are like streaming data, right? You get these data, and then they can change over a period of time. You might have to like change the data set, or you will have to like go and filter out, tweak your data sets, train your algorithms to be better and better, and it can change for different events, right? So that's another reason why we picked up Twitter dataset, because it's not a constant one, and we it keeps on changing, right? Now coming to the initial part of the project, what we will do is now we want to start off this project, which is the project initiation, right? As a part of it, we want to create an objective. The goal of this particular project is to identify public sentiments, like I said, on a particular event or a particular topic, right? So that's the goal statement for us, right? Or the objective statement. Now what is the scope of this? Because when you say the objective, it is a broader set, right? But I want to have a specific scope so that I can identify this is what I want to deliver as a minimum viable product, right? I mean, that is what I want to create as a part of this project. So the scope here I want to define is determine the boundaries of, for example, the whole data collection. Let's say I want to collect only few months of data, right? So in this case, for Twitter dataset, we have 5 months of data from 2023 January to I think around May or June, right? So we have 5 months of data which we have collected, which is publicly available information, and we will have lot of information like likes, tweets, right, and specific keywords we can extract from those, right? So as a scope, we have clearly defined that the data set is going to be having 5 months of data, and we want to also restrict our final output to, let's say I want to understand the sentiment pattern based on the number of likes, right, beyond a particular number, or between a month or a two, right? So that is what we want to scope it. So I should be able to maybe track down at a weekly level or a monthly level within that 5 months data, or I should also be able to filter out based on the number of likes, right? So that is the scope of our project, right? Now coming to the whole entire data pipeline, so how are we going to build it? So this is a diagram I think we discussed over the last 5 days, right? The whole data processing or the data preparation involves multiple stages, tasks, or workflows, right? So individual tasks in these pipeline, right, is going to be it's going to be an individual project or individual milestone in itself. For example, data collection is one activity where you will have to figure out how am I going to collect the data, right? You could be collecting the data from APIs, or it could be collecting some data from, let's say, downloading it manually, or maybe having an automated process which downloads and then sends it. Since this project is going to be an ongoing thing, we don't want to do any manual data collection, right? So one option is you can use the Twitter API, which you can directly connect to, and then you can keep on streaming the data, right? So you can keep on processing the data as and when the data arrives. Maybe you can do it once in a day, or once in 2 days, or maybe a weekly option as well is available, right? So that is the data collection process, right? Same way, the next option is the pre-processing. Once the data is collected, how do we process these, and then how do we extract features out of it, and finally go with the model analysis. Now, going into deeper into all these phases, right? The first phase, like I said, is the data collection. We are going to use a data set from Kaggle, right? And we are going to upload that into Azure storage for now, right? As a manual step. So the first process is identifying the data source. We have identified that the data source is from Kaggle. We didn't want to spend more time in creating an API, downloading it, registering an API key, etc., etc. So that's why we're just going ahead with publicly available data set, which is there in Kaggle. We will give the link for that also in the repository for today's session. Also, the data volume should be estimated, right? Like I said, we have 5 months data which is available from the Kaggle data set. So we are not like loading the system with too much data, but we have some decent amount of data there, right? And finally, we can use tools like TweePy for Python as well for collecting these data. But here, like I said, we're just downloading it manually and then uploading it into Azure storage for using in the Azure ML library. Now, coming to the pre-processing, once the data is collected, the next process in our pipeline is the pre-processing. We need to clean up these data sets because there will be a lot of duplicate tweets. There can be a lot of URLs. There could be emojis. There could be special characters. There could be some words like we call them stop words, like is, the, etc., which may not be useful for us, right? For analyzing the sentiment, right? Same way, we also want to do some tokenization. Right now, how do we tokenize and which fields we want to tokenize, right? So all these can be done as a part of the pre-processing, right? The next step is again feature extraction. Once we have done all the cleanup process, we have the tweets. From the tweets, we want to know how identify how individual words have a specific weightage. If you have attended yesterday's session, we talked about bag of words and the TF-IDF algorithms, or in fact the word embeddings, how we can convert them into vectors. So we will be using either of these depending on the type of data set we have. So in this case, we can use TF-IDF as an example. I'll also show some ngram, if time permits. I will show some ngram algorithm as well, how we can create the features extracted from the texts, right? And finally, we'll be using the scikit learn library, right, to help the feature extraction process, right? So all these libraries are part of the scikit-learn, and we can use from there, right? So that is another task in the pipeline. And finally, we will use maybe the naive Bayes algorithm or any other algorithm which is available in the industry, right, to train these models, right? So the reason why we train this model is so that we train with, let's say, a few years of data set, and then the model is able to understand what type of data we want, and then anytime you get the new data, we will be able to identify and create a pattern and visualize the data out of it, right? So that's the reason why we will be using algorithm, and we will be training the model, and we will keep on training the model as well, right? I don't know if we can show everything today, but we will show whatever we can, because within 1.5 hours we cannot build an entire system, but this is the whole pipeline looks like, right? And finally, we want to visualize using the matplot library, or maybe like Seaborn's library. We want to use these libraries to visualize and then plot them in the form of charts. For example, within charts, you can have sentiment trends in the form of word cloud, right? Or maybe showing the trends, like how whether there is a positive or a negative trend. We will show something with the word cloud for you with the visualization again with Seaborn, right? So these are different stages which we will be doing as a part of the pipeline. Now, coming to the whole milestones and the timelines, right? So this is the high level categories which we designed, which we discussed, right? We will do project initialization, we will do data collection, we will do pre-processing, feature extraction, model training and evaluation, and visualizing these reports. Right. So these are the high level tasks which we will do as a part of a project building, and that is what we are going to do today, right? Now, coming to the milestones, right? Sometimes we have so many tasks, but then we want to create milestones, right? If you're a college fresher, or if you're just out of college, right? If you join any company, right, you will be seeing that there are different tasks. There will be different categories of tasks, and a lot of people will be working on these tasks. There will be a MVP created for each of these tasks in the form of a milestone. So milestone is basically a period or a checkpoint saying that I will deliver this by so and so date. For example, here project initiation and data collection, we will do it in a couple of weeks, right? So the deadline for that is 31st December, and that is the milestone for us. That's the first milestone. Now the second milestone will be like, okay, the first part of the project is done, what will be the second part, right? That's where the second milestone comes into picture. Again, I have grouped two of these categories into the second milestone, which we will deliver by 10th Jan, the next milestone again by 20th Jan, and then the final milestone by 31st Jan. So this is how we do project planning and deliver a project, right? Whether you're working on a startup or whether you're working in an enterprise a company, right? All of us follow these kind of a timelines or tasks level split, and then we go with the milestones. Sometimes what happens, we reiterate, so we do agile methodology, some people do sprints. So the reason why I split by 2 weeks or 10 days is because I wanted to show you the sprint planning. So we do like have milestones per sprint, right? That's why it is 2 weeks, right? So same way some people follow a monthly sprint, right? Some people follow a quarterly sprint or maybe 6 months, but depending on the type of product you're working on, the sprint varies, right? And the sprint planning depends. So these are the different milestones and timelines which we are coming up with this project. Before getting into the ML pipeline, so I also wanted to identify some of the risks, right, in this whole project. So the first one I feel is the data privacy issues which can come into our project, because we are going to read public information from the internet, right? In the sense, the social media platform. So there could be privacy issues. So we need to account for that as well. So whenever you're planning a project, make sure security and privacy are considered as a key factor. So always think privacy first and security first when you're building something based on a public platform, right? The other thing is the API limitation. Let's say we are using Twitter's APIs. There could be a case where the data is huge, so your API calls could be failing or be throttled by the API from the Twitter side. So make sure that you are planning for these limitations when you're designing your architecture, right? So these are different risks which you need to consider as well, along with these tasks and the milestones, right? Now there is another tool which you can use in the public platform, right? In GitHub itself, right? If for example this is my GitHub Tech handbooks which we created. So me and Aditya will be posting all the sessions or anything public which we do. We started posting all these in this particular organization, and you can see that we have multiple days. These are different repositories. We call this GitHub organization. In the GitHub organization, there is an option called as projects. We can go to the projects and create a new project for ourselves. Let's say I'm going to build a Twitter sentiment analysis project. So I can go and plan my project and use this planning tool to categorize all these tasks and then move these tasks as a like a timeline or a swim lane, right? We do sprint planning based on that. If you had used tools like Jira or maybe like Azure DevOps, it's almost similar. GitHub provides something similar for us, right? So I'm going to go and say I'm going to use this a team planning project, right? And I'm going to give a name for it, right? For example, I'm going to say that this is Twitter analysis mini project, right? The moment I create this project, I will have a dashboard for me, right? And this dashboard, again, anybody in the team, let's say there are 4 people in the team. So right now me and Aditya are the team members. So we use this mini project and I can go and create different tasks here. So for example, I'll say data collection is one particular task, right? So I can go and say data collection as a particular item, right? Sorry, I can go and say create a draft. So if you see here, I have a data collection category, which is a draft item. Now, if I want to move this, for example, let's say Aditya is going to work on this, right? So I will assign this to Aditya. You can convert this into an issue, and I can assign it to Aditya, and I can leave it there, right? I will create a lot of different tasks here, and people who are free, they can come and pick up the task from the to do item, right? So that's how we start working on. So this is like a backlog. To do is the backlog where people can come in and then pick up a particular task. Now let's say data collection is going to be worked on by Aditya. Aditya moves this from draft to in progress, right? So this is how, let's say I'm a scrum master, or in the agile methodology we have a scrum master. So the scrum master comes here and then looks at it, and then they can identify what tasks are in progress, what tasks are done, etc., right? So whenever Aditya is working on it, he moves to in progress and then he moves it to done when he is done with it, right? So this is another way in GitHub which you can leverage. Again, I just wanted to show you, for example, the Azure AI cohort itself. We initially were from different geographies, right? So I am in Chennai, Aditya is in Hyderabad. So we wanted to coordinate within ourselves. So we created a project here using the same GitHub um, organization, and we had different tasks here. If you see here, we started creating decks, we started creating hands-on guides, etc. We were using this to plan our activity, and then we have done with it, right? So this is how you can use this planning tool, which is available in GitHub. All right. Now coming to the hands-on part which you have been waiting for, this is what we are going to finally build, right? We have a data set, we are going to upload it to Azure storage, and we are going to use the Azure ML service to create this end-to-end pipeline, right? So don't get afraid with looking at all these box. I will cover all these, right? Whatever tasks which we saw, the pre-processing and the data processing pipeline tasks, all these are converted into visual representation using the designer tool within Azure ML, and these can be run as a pipeline within Azure ML, and that's what we're going to see today, right? With that, I'll hand it over to Aditya. So he will. So initially, just to get a hang around, we will be using a new the yesterday's data set, right? So that's what Aditya will cover, and then I will, once I take over, I will show you how you can use Twitter's data as well, and then I'll cover how you can improvise on what Aditya is going to create, right? Yeah. Again, if you guys
Uh,
have any questions, do post it in the comment section, so we'll be able to answer that as well. I think you can share it, Aditya. I cannot hear you. Nope.
Now?
Yeah.
Okay.
That
Okay.
happens
Cool.
with that with this mic.
With this
Yeah.
mic, yeah, it
That's why I
automatically
use the
detects the.
wired. Yeah. That's why I use the wired one. I don't you go with the
Yeah.
Bluetooth one.
Okay. So let me just quickly share my screen.
Technology ditches us in the last moment.
Yeah. So hope you can see my screen.
Yep, I can see it.
Okay, perfect. Cool. Hi everyone. Let's start with our demo. So if you have followed our previous session, the NLP session, it's going to be in a similar format. I'm going to use the Azure AI Machine Learning Studio. So for those who are attending this for the first time, let me show you how you can navigate to there. So the simple thing is this is the portal. If you don't have an Azure Active Azure account, just go and register for an Active Azure account. If you are a student, you'll get the student pack. You don't even need a credit card for that. But even if you are not a student, you can still get some $100 or $200 worth of credits for free of cost. But for that, you need to provide the credit card details. But once you are registered, you can land into this page, and here you need to select the Azure Machine Learning Service. If you don't see it in the home page, you can just search in the search bar, and once you are here, just click on Create, say New Workspace, and subscription. Like once you have registered, you'll have a default subscription. Just select that subscription. You need to select a resource group. Resource group is for grouping of resources logically, and then you just name your workspace. All of the other details like the storage account, key vault, like say if I say it as test workspace, so all of this will be created by default. You don't have to do anything for that. So once that is done, click on create, review and create. It will be reviewed. If everything is fine in an acceptable state, you'll get an option to create. So you just have to click on the button and create the resource. In my case, I'm not going to do that because I already have an active resource for this. So I'm going to use that. So once you go to my resource, this is the one that I've just created, that I've created yesterday. So in this, on the overview page, you have an option to launch the studio. Just go scroll down a little, and you'll see this option. So once you click on launch studio, it will open a new portal, which is ml.azure.com, which is nothing but your Azure AI machine learning studio. So here, once you click on notebooks, you'll be able to write your Python scripts the same way you can write in the Jupyter notebook, right? So these are the demos that I've done yesterday. So let me just create a new file and name it as project demo and click on create. So now our project demo file is created. So for this to execute, we need a compute. So we are getting a default compute here, which is the serverless Spark compute. So the session is here. You can clearly say the session is not started. First, let me do a print statement. I'll say welcome, right? And let me execute this. This will trigger the session. So once the session is triggered, it will be active for some time. So from the next steps, it will become really easy, right? So it will take a couple of minutes and then print a welcome statement. So let it do its work. Meanwhile, we can start writing the code in the next block. So first thing, as usual, uh, first thing we need to do is we need to install all the required libraries like matplot library, Cburn, NLTK. I'll explain what each library is for. So in my case, I'm not installing it because I already have this installed. So I'm importing this libraries, right? So let me explain each line here. I think this will be in a waiting state until this is completed. So meanwhile, let me explain what each line denotes. So the first one is the matplot library dot pyplot, which is used to create the visualizations like maybe a line plots or a bar graphs or the word clouds, right? So basically helps you to visualize your data in a better way, right? So and then we are doing importing the Seaborn. It extends Matplot library for advanced visualizations with themes and improved aesthetics. And then we have a library called NLTK. So NLTK it stands for Natural Language Toolkit, and we've used this. If you've followed the yesterday's session, we used the same library yesterday when we are demonstrating the NLP example, right? So this is a library for text processing tasks like tokenization or stop word removal. All of these methods are provided by NLTK, right? And then we have pandas, and we are aliasing it as PD so that it becomes easy when we are coding. So pandas again is a very powerful library for data manipulation and analysis, used here for working with a tabular structured data, right? And we are importing RE. RE is a library for regular expressions. RE stands for regular expressions, used for pattern matchings and text cleaning. So we'll see where we'll use RE going forward. I think in the last few examples or in the last 5 sessions, we've never used RE. This is the first time we are using RE, right? And then I think NLTK corpus, NLTK tokenizer are part of NLTK. So from there we are using stop words and word tokenizer. So we'll talk more about that. And then we have date time. So this will handle date and time, and here we are using it to generate the timestamps. And last but not the least, we have fetch underscore 20 news groups, which is from sklearn dataset. This is the same dataset that we've used yesterday for analyzing the news articles. So we are going to use the same thing because I wanted to do something with the dataset that's already there in sklearn. So instead of getting the tweets data, I am considering the articles that are there in this 20 news groups dataset as tweets. So that becomes easy for importing and playing with the data, right? So I think this is still processing. Sometimes it takes a little longer time. Let it go. Let it take its time. So I think yeah, this step is done. It took approximately 2 minutes 56 seconds. Now the import step is happening. So this will take few more seconds. So by the time we'll go to the next step. So the next step would be to ensure all the required NLTK data is downloaded. So as you've seen, we have two things here. One is the stopwords and the other one is the word tokenizer. So let's download the stuff that's needed for these two. So one is we are going to I think this is also executed. Let me just execute this. This download will take another few seconds. So NLTK.download stop words. This downloads a list of common English words. Stop words are nothing but the words like I, is, was, and the, right? These are the words without which we don't find any much meaning in the whole sentence. But these are often removed during the pre-processing stage, right? And then we are saying NLTK.download PUNKT provides a PUNKT tokenizer which splits the text into sentences or words. We'll be using this going forward. And then the next step is to clean the data. So let me just add a new code block and get the code for cleaning the data. So this won't take much time because this is just a definition, so it should be executed easily. So yeah, so this clean tweet definition is registered now. So what are we doing here? The first one is we are, I think the uh, comments that we've added speaks a lot about this. So first one is removes the URLs. Here we are saying HTTP slash s place matches the URL patterns like HTTP, like anything which is with HTTP or HTTPS, all those will be matched. We are removing all that stuff. And then you see something called as @/ w place. So this matches the Twitter handles, basically any username or any mentions that we do. If we tag @Aditya, if you tag me on Twitter and get that tweet and pre-process that, it will remove my username from the tweet, basically, right? So and then we are removing the hashtags. I know most of you understand what hashtags means. We have a hashtag and the word, which will help you to get a better reach and help the algorithms process the data well. So we are also removing the hashtags here. So for removing the hashtags, we have RT something, whatever you see here, right? The bracket slashes and the bracket close place, right? That will identify the sorry, not that hash. Will actually identify the hashtags, and then the RT will remove the RT prefixes. RT is nothing but retweets. RT stands for retweets, right? So it will remove all that retweet related data from the tweet content, right? And then we have special characters removal, which removes non-word characters. Say if you have a smiley or if you have a heart symbol, so all of that can be removed using this /w. And then the last one is tweet.lower, which means converts the text, the complete text, to a lowercase for uniformity, because there are chances where few tweets are with completely caps and few tweets are with complete lowercase. So just to make a uniformity, we are making everything to a lowercase, right? And then let's remove the next step would be to remove the stop words as part of pre-processing. So let me get that code. Let me execute this. So this is executed. Let me take scroll up a little. Yep. So this sentence actually creates a basically common set of English words to be removed from text during the pre-processing, and we are also mentioning the language name as English, uh, right? And then the next step would be to write a function for pre-processing of each tweet, right? So we'll be writing two functions. One is for pre-processing of individual tweet, and after that we'll also write a definition for pre-processing all the tweets, a group of tweets, right? So let's execute this definition. What does this function do? Cleans first is it's cleaning the tweet. Then it's readable, clean underscore tweet, right? So that will clean the tweet. And what is that clean tweet? So we have already defined that function on the top. So we are, as part of clean tweet, we are removing the URLs, removing the mentions, hashtags, retweets, special characters, and finally converting it to a lowercase, right? So we are first calling that clean tweet, and then the next one is word tokenize. So it will split the clean tweets into the words using the word underscore tokenize method. And once that is done, it will remove the stop words. So filters out the common words using the stop words method, stop word set. And the last one would be to recombine all the splitted words into a single string, right? So that's what will be returned. So if you see there is a space, so all the splitted strings will be combined with a space. I mean, like between each sentence or between each word will have a space. And then the next step is to write a function to process data and generate the visualization. So first let's process the data. So as we have a method to process a single tweet, now let's write a method to process tweets, which will take a data frame as a input. So let me copy that code. and execute this. Yeah, this is just a definition, so it's executed in a second. So what are we doing here in this? It applies actually the preprocess underscore tweets to the text column of the input data frame, and this is creating a new clean tweets column. So basically, this preprocess tweets is nothing but the method that we just created for an individual tweet. So it's going through the text and applying this pre-processed tweet on all the items, right? And then the next one is to generate the visualization. Before that, let's store this data in some folder path. So let's create a folder with outputs, and let's store a data. Let's store the data there. So for that, it's a simple command. So we are initializing a variable called output underscore dir, which is equal to outputs, and we are checking if the path already exists. If there is some path with the name outputs, if the path doesn't exist, then that's when we are saying make dirs. I think this is a common term, a common function that we also use in the command prompt. So we are saying os.make dirs and passing the path. If that doesn't exist, it will create a new path with the folder outputs, right? And then let's create a word cloud. I'm not sure if you heard this term of word cloud. So we'll be seeing that in next few minutes. So let's create a word cloud out of this. Let me just quickly execute this. Oh, interesting. What did I miss? Just a second.
I think you have to import word cloud in middle.
Uh, so it
Import is
says
not there, right?
words word cloud. Data frame is not defined. I think I
Oh,
haven't defined the data frame
data
actually.
frame. Okay.
Yeah. So, but I remember calling the process tweets, which will create the data frame. We just double check once. Outputs. I've added the folder. Before that, we have done the processing of tweets. That's also done. Uh, where did I miss to call the pre-processed tweets? Did I miss to call the pre-processed tweets? I'm calling pre-processed tweets. After that, I'm creating an output directory, which is correct. And then, oh yeah, so I think I missed something. So let me just rerun this again. Did I import WordPress already on the top? But cloud is not here. Cloud is here. Then what is error now? Somewhat cloud import. Okay, just remove this. Still the data frame should show an error. Data frame. Where did I miss the data frame? From ideally the process tweets should create a data frame, and we have already initialized it. Just give me a second. Let me uh, go to this one, and okay.
Yeah, the scope is within that method, right? So
So basically, process tweets definition is completely
within that scope. Yeah.
within that scope. It's all splitted. I've splitted it. That's the reason for that.
Yeah.
And the scope is changed. Let me copy this to a VS Code and then get the process tweets method. Yes. So let's go back and so let me just remove this. Remove this. We'll execute the process tweets one more time. So let me execute the process tweets first. So as part of process tweets itself, we are creating the clean tweets, and then we are creating the output directory. And after that, we are importing the word cloud. And here, once we import the word cloud, just a second. So this, if you look at this one, the word cloud stuff, it actually combines all the clean tweets into a single string, which is all words with a join, right? And then generates the word cloud using the word cloud library, and then that will also display the word cloud, the plot.slow show, and after that tweet length distribution. So let's first see the output. Maybe that way. Oh, okay, it's still showing some issue. Okay, no, it's just a definition. So next, what we've written is we have written the tweet length distribution. So this piece. So what are we doing here? This actually computes the length of each clean tweet and scores it in the tweet underscore length column. If you see here, we are saying data frame of tweet underscore length. We are creating a column, new column called tweet underscore length in that tabular format. And after that, we create a histogram with KDE. KDE stands for kernel density estimate curve to show the tweet length distribution. So and we are passing that KDA as true and bins as 20, right? So and after that, so first let's execute this. Let's execute with a sample data first in the next step. So this fetch underscore 20 news groups is something that we've used yesterday also. This will load the SCI space category data, which is nothing but the science category uh, articles on that news group, news page, right? And for now, we are considering these as tweets. And after that, we are taking only the data set of first 50 records instead of overloading it because we are just using this for demonstration purpose, and converts that first 50 samples into a data frame using the text column, right? And once this is done, now let's do the process tweets, which will give us the output of the visual representation that we are talking about. Process PD. What is wrong? Process tweets. Module not found. Okay, this is not executed properly. SDF, which is correct. Uh, Let me just do it one more time. Okay, module not found. Which module is not found? Last process tweets. Oh, word cloud. Okay. Okay. Why is word cloud not imported? Let me just import this one more time. Let me do it here. Word cloud. Okay. Let me do a pip install once.
Yeah, it is lowercase word cloud.
It's just lowercase, right? That's what I'm
Yeah,
checking.
yeah, it is lowercase.
Lowercase. Okay. So this will take few seconds. I think. So the pip install did not work for word count. Word count. So once this is done, then we'll import the word count and execute the method one more time. So yeah, this is done. So let me add this code. So this.
I think you have to do word cloud.
Oh no. Correct.
Yeah,
CL word CL. Which means there is some other library called word count also. That one was also successful. Okay,
yeah.
now let's import word cloud from this one. So yeah, now this is successful. Now let's execute the process waits one more time. So this is also successful. Um, so let's refresh the news groups data and the data frame. So now let's process the tweets. Perfect. So now see, first thing is we are getting a word count, word cloud, which will show you like if you have this we usually use when we are taking some kind of like say in recent session that I gave today morning, I was using some application for generating the word cloud where I asked people what comes to their mind when it comes to diversity, right? So and people were writing a single sentence or a single statement on what diversity is for them. So whoever gives the same name multiple times, that specific word will be shown in a uh, with a bigger font size, right? So you can clearly say see some words like space, NASA, mission, year one, Earth, system, right? Other words which are like study, cost are not much visible, right? And then this is the distribution of the tweets length. So once this is done, the next step is to print the processed data, which is the data frame. So let's quickly print this, right? So now you can clearly see what is the data before and what is the data after processing. Uh, this is the top data set is without cleaning, and the below one is the clean tweet and what is the length of each tweet, right? So yep, this is how it works if we are using a simple notebooks from the Azure Machine Learning Studio. But all of this, whatever we are doing, is unstructured, right? In sense like we are writing a single statement, we are writing a method, checking if it's working or not. We've seen a lot of issues when we are executing it. We saw that pip is not installed correctly. If this happens in a production system, that system would break, right? Just that we are doing a trial and error. All of this is working, but how can we structure this whole thing in a better way so that people can easily understand and relate to it, right? That's something Ajay will show you now. Over to you, Ajay.
Sure, thank you. I think Karthik also asked a similar question. So where will be the directory of output, right? So there is an outputs directory. So where will that be created? So that's a very good question, Karthik. See, if you look at what Aditya showed, he created a notebook, right? That's like a temporary VM, right? So the whole notebook is running in a temporary compute instance, right? Now, when you use in a production system, we cannot afford to create these output PDFs or the PNGs in the temporary system, right? So that's why we upload it into an object store or a blob store, right? I will show that in a bit, right? So how you can use an end-to-end ML pipeline. So whatever Aditya created, it's good for learning purpose, right? So whatever we did, yeah, we leverage ML service, but we created our own notebook and then Jupyter notebook and we did it. But then when we go to a production grade system, right? Since our project is a end-to-end product, right? So we cannot afford to lose these data. We cannot afford to execute one by one, right? So we are doing it manually, but then how do we do it automatically, right? So that's what I'm going to show. I'm just sharing my screen. If we can, Aditya, if you can push it to the stage. Aditya, you have to go and make my screen share. Yes, cool. Thank you. So if you see, this is my portal. So I have created a workspace. So whatever Aditya showed, right? You can go and create a workspace. I hope most of you have done that. Now, when I go to this workspace, I just created it in the name of Azure AI Cohort Workspace, and I can click on Launch Studio. Right, in the Launch Studio now, apart from the notebook, so you would have created a notebook which is just the start of it, right? You see there are a lot of other options which are there, right, for the same purpose whatever we just did, right? So we are going to use pipelines, we are going to use data, right? We are going to use jobs. There is something called models, there is environments. I'll cover one of each one of them, right, whenever I am touching each of them. So as a start, we are going to design an end-to-end workflow, right? So I'm going to use the designer for that. So in order to create an end-to-end pipeline, right? So whatever we did, the pipeline which I showed you, right? If you remember my diagram here, this one, the data collection, the data pre-processing, feature extraction, modeling, we are going to create this pipeline. So we call this the ML pipeline or the data processing pipeline. So to create that, we head to the designer. In the designer, you can create a new pipeline, and this designer is a UI based framework. You can just drag drop stuff, you can add Python code to it. So whatever code Aditya wrote, I'm going to exactly copy that code into the pipeline. So in order to do that, I'll come to the designer, go to the classic pre-built option. So you can go and create a new pipeline using pre-built components. So we are going to use or leverage existing components built by Azure so that we don't have to write a lot of code. So if you look at Aditya had written a lot of code, custom code for removing word library. We were using a lot of existing libraries to do same stuff, right? I mean, if everybody is doing the same thing, why do we even have to write that code, right? And the moment you write that code, you need to test it, right? In a production environment, you need to test it. Now, why do I need to test it again and again, right? So I'm going to create a new pipeline here called as tweets pipeline. I'm just naming that pipeline as tweets pipeline. There are predefined components. If you see, right, there is a predefined data collection here. There is component as well. Data is where the data set comes into picture. So I already uploaded a couple of data sets here. In order to upload the data sets, you can head to the data section. Under assets, you can go to data. You can create a new data here. You can provide, let's say, Twitter data set hyphen example, right? I'm going to say that it's going to be in the tabular format. I'll just say next, and I have the CSV file. So this is the Twitter dataset. I'll show you the Twitter dataset. This is the Twitter dataset. There is tweet ID, there is username, the tweet itself, there is retweets, how many retweets were done, there is likes, and there is a timestamp. So these are the only fields which are there. This dataset is available for multiple months. If you see here, January, February, March, April, and May. So for 5 months, we have the dataset, right? So I'm going to upload this particular dataset into the library here, into the dataset option here. So I'm going to click on from files and I'll just say next, and we are going to upload this into the blob storage, right? So like I mentioned, so locally Aditya would have had that data set or he would have used a method to import that, right? But in a production system, right, we will have to use these object storage or any storage which is there in the cloud. So in this case, I'm going to use the Azure blob storage, right? I can also use the data lake if let's say the data is huge. Like I said, if you have a a month old data or a week old data for Twitter tweets, it will be huge, right? So I'm going to use blob storage for this smaller data, but if you have huge data set, you can use this. And I already have existing blob storage created called as workspace blob store. So I'm going to use the same thing. I'm not going to use anything new. And this gets uploaded into this path. I'm going to upload the file here. Let me quickly upload the Twitter data set. So I have the Twitter data set here. So I'm just uploading the Twitter data set, right? And I'll just say next. And this, if you look at it, it automatically identifies this is a delimited file. Data sets with multi-line data. I'm just selecting it. So automatically your create data set identifies and parses it and shows up. See this? It's automatically done that. Now I can do a review and then create this data set. So this is how you can upload it once, and you can have an automated way to do it as well. So you can use the Azure CLI and the Azure SDK to do this in an automated fashion. So this is how you do it in production. So you do upload the data set using the data asset here. Now coming back to the designer studio, we created a tweets pipeline, right? In the tweets pipeline, now I can see that whatever data set I uploaded, it is visible here. So I'm going to drag and drop here. My data set is now available for me, right? Now to use this data set in my Python code, right? So I can use something called as Python. There is a data component. So data is done. We have the data. There is something called execute Python script. You can write Python script. We'll start with the basic and then I'll show you how you can improvise. So we have the data set ready. Now we have the Python script. So this Python script is exactly the same whatever Aditya had done. I will just copy paste it and then I will explain it while it is running. So I'm just copy pasting the exact same Python script what Aditya did, right? So I'll save this file, right? Then there is an option to configure and submit. So this is where you can configure this designer pipeline to be run like a job, right? So imagine it something like how you write code in production with a GitHub repository backed code, and then you have a CI/CD pipeline and then deploy it in your production systems, right? So same way, in order to run your whole pipeline, right, the Python script, and then use your data set to execute and then see the data, you have to set up a pipeline. There is something called experiment, right? You can go and create a new experiment. I already created an experiment called as Azure AI Cohort runs. If not, you can just click on create a new and then you can create a new experiment, right? I'm just reusing an experiment. It's like a what do you call a logical grouping, right? That's all it is. And then I am going to give a job name. So every time you run this, it will have a different job name. I'll show you some other job names as well. You can give some job tags, you can filter out, and then I'm going to the next step, right? As a part of the next step, there are inputs and outputs. I'm not providing anything. In the next step, there is a runtime setting. Now this whole Python script, the data set, all this processing needs to be run on a VM, right? Like how we saw in Jupyter Notebook, we used a compute instance. Same way here also, we can provide a cluster of machines. You can use Kubernetes instances, right? Or you can attach it to an existing compute, or you can create a compute instance. So I created a compute instance already called as Twitter DS install. If you don't have it ready, you can click on the create Azure compute instance option here. You can select a, memory optimized or a general purpose VM here. I just created a memory optimized VM with a 16 cores just to make sure our demos go fine. So I created a bigger machine here. Once I create it, I can use it for all my pipelines, right? Again, you can have any number of clusters or any number of instances. So I've created that here. By default, again, I'm using the same data store. So what happens is every time whenever you have multiple stages, so Karthik, this is where your answer lies, right? So every time, imagine it like different steps in a pipeline, right? Now the output of this step needs to be stored somewhere. So the output can be stored in the object store here, right? So that is why um, we have the outputs. Whatever we write in that output directory, we can directly store that in the object store, and in the next step we can download it from the object store, or it is readily available for us in the step. I'll show that in a bit, right? And then we can trigger it. Right now let me trigger this step and then I will explain you the code and then show you as well, right? Meanwhile, before, I think it is going to fail because what I did realized is I did not link these two, right? I have a data set, I have a Python script, but then what is the input for this, right? Here, if you see, there is an option to create a data output, and then you can just drag and link it to the data set. If you have multiple data sets, you can link it to data set 1 and data set 2. Right now, we have only one data set, so I'm just going to link this here, right? And I'm going to save it again. Obviously, this is going to fail. If I click on the view details, it will take me to the pipeline job section, right? And then see if we see. directly the Python script is running, it doesn't have the data set. So I'm pretty sure this is going to fail, right? Meanwhile, I'll come back to our designer here, and then I'm going to trigger it again. Yeah. So this is triggering. So if you see here, yeah, it has failed. The previous job failed. Now the new run is triggered. Let's open the new run. And this is where you can see the outputs and the inputs, right? So if you see here for the Twitter data set, you can double click and you can see the output. The output, if you click on the preview data, this will show the output of this data set. Output of the data set is the data set itself. So if you see here, these are the columns, which is the output. Same way, once the Python script is executed, we will also be able to see the output for it. Now, if I double click on this, it will pop up a screen like this, and you can see here, you can see the status of this particular job. You can see the parameters, which is nothing but the script, what is the input, what is the output, where it is going to write. Input is nothing but the previous step, what is the run setting, etc. There is this output plus logs. So this is where you can see all the logs of that particular program. In fact, the program is completed, right? Now you can see that all the pip installs, whatever we did, right? Whatever you do as a print statement. For example, I just printed all the columns in that particular data set, right? So if you see, I can see that these are the different columns, right? This is a statement which I added. I'll show in a bit, and these are getting printed, right? So this is how you can see the logs. So if you go to std log, you can see the all the logs. If you go to the data outputs, you can see the directories which you have created, right? Now see that again, this is the data set. We can see the output directory, whatever Karthik you were asking, that is where this is, right? When we create, initially this doesn't show up. Once you create this output directory, it just shows up here. Within the output directory, we stored those word count and the tweet distribution, whatever Aditya showed in the form of a notebook. All these are automatically generated and then pushed it into this output directory, right? And you see that based on the Twitter dataset, this is what I see, like MR, new, add hard. Looks like there are a lot of data which I need to still clean up, right? These are not good data, right? Same way the tweet length distribution is also shown here as a graph, right? So all these can be pushed into that output directory. This output is specific to this particular run, right? Now, if I do another run, this output directory will be gone. So the wise thing is to upload this into a object storage or the blob storage, right? And again, if you see here the data set, if you see, if I click on this data set option here, it shows what are the new columns which got created. Like Aditya showed, right? When he printed the data frame, he was able to see the new columns, which is the cleaned tweets and the tweet length. You see here, I also am able to see the cleaned tweets and tweet lengths. In the previous step, it was not there. Now it has got created, right? So that's the output of this particular step. There is also an option for us to, if you see here, let me close these, right? If you double click here, there is an option for us to see the storage, right? So which is the object storage. So you can access the whole data in the form of Parquet files or visualized files in the object storage. So every time a stage is executed, it is all pushed into the object storage, right? This is what I was telling Karthik, right? When you move from one step to another, all these data gets pushed into here. So visualization is again pushed in the form of JSON. The data is pushed in the form of Parquet. Parquet is another format of machine learning system. So these are all the data which gets pushed as a part of the output step. Now coming back to the code itself, right? Now that we did the same magic, whatever we did there in the notebook, let's understand what changes we did for this, right? Now, in order to run this Python script in the ML Studio, right? So the first function which gets triggered is the Azure ML underscore main, right? We have to define this particular function, and there are two arguments for it: data frame one and data frame two. And if you visually see it, data frame one is nothing but the input of the data set. That's what we did here, right? So whatever data is present in the data frame one object will be nothing but the data which is coming from this data set, right? And that's why I'm assigning this data frame one into a data frame object, and then I'm using that data frame object to extract the text, and then I'm doing some pre-processing on it, right now I don't have data to frame two, so I'm just ignoring it. Meanwhile, if I want to access resources in the workspace, which is this particular Azure system, I can use run.getContext to get a handle of the run, the whole job run, the whole pipeline run. And also, if I want to get access to the workspace, I can do run.experiment.workspace name to get the workspace name. So I have two controls within the pipeline. I can, within the Python script, I can control my job which is running, and I can control my workspace, right? Now I have stored my data frame in the df here. I was printing the columns here, which you saw in the log statement. I'm cleaning up using the pre-processed tweet. This is exactly the same code whatever Aditya had written, right? So he did clean up the tweets, right? He did clean up the tokenization. He did a lot of things here, right? It's the same thing. We are creating the same output directory. We are creating a timestamp. We are creating a word count. Everything is exactly the same, right? I mean, I have not changed much. Only the return type is a DF. So that's what we are returning. So this is how you can use a production grade, what you call end-to-end my ML pipeline, right? Now, how can I improve this? Again, this is not enough because I have written a lot of custom code, right? So for example, cleaning up of these tweets, right? I don't want to do this cleanup every single time in the code, right? And if I need to do this, I have to test it out. I have a lot of effort here, right? In the code. Again, code is a maintenance headache, right? So what I'm doing, I'm removing this whole code completely. Instead, and I'm going to just comment this, or I will just remove this, right? So instead, what I will do is I'll just save this and then I'll show you. So I'm going to save this and then I'll close it. So in my code, I've removed the cleanup process and I'm going to use some predefined components which are there, right? So what I can do is first I want to ignore some of the fields which I don't need, right? For example, tweet ID is some field which I don't need. I don't need all the data to be pushed into the Python script, right? So I'm going to say there is something called as select columns in a data set, right? Again, I'm going to drag and drop, right? Here, I'm going to now redirect my pipeline from, I'm going to remove this arrow mark, which was going from the dataset to the Python script. I'm going to redirect from here to the dataset, right? And again, from the output of this dataset, I'm going to feed this to the Python script. Now here, if you see here, I have to configure the select columns. So this particular component, what it helps us is in doing is it can filter out some specific components from the dataset directly without any manual coding or something, right? So I'm going to say that with this particular rule, include only the column which I wanted, right? See, if you see, the moment I clicked on it, it's showing me all the columns which are there. So I want to have the text column. I want to also have the likes column, and I also want to have the timestamp column. I don't need anything else, right? Because I'm going to use only these three to do some processing. Text is for the tweets, likes and timestamp. I want to filter out some specific data. So I'm going to use only that. That's all, right? Those methods, whatever Aditya was showing, he has written manually using libraries and stuff. We have just removed that using the custom component here, right? I'm going to save this and let's go and run this, right? Meanwhile, what happens is this output, right? This particular output is again fed back into the data set here, right? Now, if you see in the frames here, we were using text column here, right? Now what happens is when this particular component converts that particular text component by removing and filtering a lot of data, it will create a different column, right? And that column name is going to be pre-processed text because again, I'm going to do a lot of pre-processing, right? Again, in this case, I'm just going to remove columns. But if let's say I'm going to add some more stuff, for example, let's say I'm going to remove duplicate rows as well, right? Let's say remove duplicate rows. I'm going to throw in some existing columns, existing components which are there, right? Again, I'm going to remove this from here. I'm going to introduce this here. I want to remove some duplicate data, so I'm going to point this here and then point this here to the dataset one. I'm going to come here again. What column, what rows I want to do, right? I mean, what rows I want to look at and then dedupe, right? I want to look at only the text column because in the text column I want to remove some duplicate tweets which are there. So other than that, other columns I can have, right? So that's all. I don't want to do anything else. There is also stop words which we want to do, right? I mean, we want to configure stop words, clean up a lot of data which we said, right? So there is something called as pre-process text, right? See here. Again, I'm going to expand this. I'm going to remove this link here, point this particular data set again to this pre-processed text, and pre-processed text I'm feeding it to the Python. Now in the pre-processed text, if you see here the language I can configure, it's right now English. Expand verb contraction. If I want to do all these stuff automatically without any bit of code, I can do this using the pre-processed text. Removing stop words, like I said, we had a library to do that. That is getting done here automatically. Lemmatization is a concept which we discussed yesterday, right? That is automatically done here, right? If you want to detect sentences, again, you can do it. You can normalize stuff, removing special characters, removing duplicate characters. That is also done here. We talked about email address removal. That is also done here. Removing of URLs. That is also done here. A lot of these unwanted characters, special characters can also be done here, right? Removed here. Now, which column needs to be done, removed? or which column needs to be processed, I'm going to give that column as text because that's where our tweets are, right? That's all. We don't have to do anything else. Now if you see here, without writing any piece of code, we have selected some columns, remove duplicate rows, and then pre-process some of them. Right now, coming back to the Python script, like I said, once the pre-processed text finalizes and creates an output column, right, that column is going to be called as pre-processed text, right? It's not, I will show it, I will correct it, and then I will just show it so that we can have a successful run. So the column name is going to be pre-processed space text instead of the text because that was a column which we had, right? I'm not going to change anything else. I removed some functions like I showed you. I removed some methods whatever Aditya had returned, right? So that's all. We don't have to do much here, right? Let me run this. While we wait, again, how do we go and debug? If let's say something fails, you can click on the view details here, or you can navigate to the option which is here. So there is something called jobs, right? If you go to the jobs, you can see it, or you can go to, if you go to the jobs, if you remember, we had experiments, right? So you can see that under experiments, if you go to experiments, it will see, you can see all the jobs here, right? So I had been running multiple different pipelines, so that's why you see multiple. Tweet pipeline is something which we created. You can also go to the pipeline section and you can directly go to the pipeline here, right? That is also another option, right? So there are two options, one is jobs and pipelines. So I'm just going to the pipeline here, and you can see that now our pipeline, our components are getting successful, right? So for example, the first component is successful, which is selecting a particular column. Now like I said, every particular component or a stage, right, has an input and an output. Now you can see the output logs here. You can maximize this. I'll remove this clutter. So you can see here, I can see the output logs, whatever that particular stage did. I can also go to the data outputs and I can see what output got accessed here, right? And again, this is object storage. I can click on the preview data. This will show me the columns which are coming in. What we did in this particular stage is we removed the tweet ID, we removed username from this particular column data set, right? If you see, only 3 columns are coming, the rest all are gone. So that is how this particular stage has been processed. Now coming to the next one, this remove duplicate rows. I don't think we will be able to see duplicate rows, but we should be able to see some pre-processed text. Like I said, in this particular component, we will be creating a new column called as pre-processed space text, right? So we should be able to see that in a bit, right? I'll show it to you. Again, meanwhile, you can go and look at the debug logs. You can see that how each of these are getting processed, right? You can look at the logs. If there is something fails here, you can come here and then debug them, right? All these are present here. So you can look at yesterday error logs of the processing. You can look at execution logs of that particular pipeline. All those can be navigated here, right? So this is taking a bit because what the pre-processed text is doing is it's cleaning up each and every row, right, to see what type of data it has. It is removing stopwords, etc. One additional feature what we have in this component is, if you see here, there is one option here called as stopwords, right? So one is a data set which is coming to this pre-processed text. There is also something called a stopwords. What this means is you can provide your own custom stopwords. If you remember, I just showed in the previous run, right? Where was it? I think I showed you where it was having have, had, and things like that, right? Those can be configured in a custom fashion. If let's say you have a data set for it, that data set can be fed into this stopwords. So what this pre-processed text will do is it will including the existing stopword it knows, it also includes the custom stopwords which we can give. This is where privacy and all those can be configured, right? If let's say I have a privacy word, I don't want those text to be processed, I can do that using these stopwords, right? This is a custom way in which you can plug a different data set into it, and then this will filter out all those. Now coming to this particular steps output, let's look at the output. So I can come here and then click on the preview data. This will show us the output. So you see here, there were only 3 columns earlier. Now there are 4 columns. The fourth column is nothing but pre-processed text. So if you notice here, all the or is gone, dots are gone. Party, I think it was a uppercase. Now it's all lowercase, right? It is now creating all these filters, and it has pre-processed these texts based on whatever you wanted, and that's what we wanted, right? That is what is done by the pre-processed text stage. or the component, right? It's otherwise called as module as well. If you see modules or components in your documentation, that's what this does. Now finally, coming to the Python script, again this was successfully executed. Again, if you go to the outputs, you should be able to see the word cloud. Now this time I think we should have much better data. If you see here, if we compare this with the older runs, right, let me show you comparing both these, right? You should be able to see how this particular data has been fine-tuned much better, right, compared to the older run. So in the older run, if I go to the outputs and logs, and if I show you the outputs here and word cloud, the word cloud showed us, yeah, so there is a Mr. New, add, hard, tags, maybe something like that, right? Now you see here, it has some much more better data because we have filtered out a lot of those data, right, from here, right? And also there were duplicate rows. Maybe there were duplicate tags. If you see your tags is gone and become less, right? Same way hard is also less, right? That means there were a lot of duplicates, duplicate rows or duplicate tweets, which now have been removed from this, right, data set. Now in addition to it, I also realized that okay, I want to now do filtering based on, let's say, number of tweets which are more than like 10 likes, right? I want to do that. Now how can I do this, right? Now I can come here back to my pipeline here, right, in my Python script. I can come here and now I can do my custom code as well, right? So what I'm going to do, I'm going to create a filter tweets function. So I will have this function. I already have the code here. So what this code does is, let me maximize. So in the filter tweets method, I'm passing the number of likes as 10, and I'm going to select only April data, right? So like I showed, there were 5 months data which was available. I'm going to pick up only 1 month data which are more than 10 likes. And if you see the column name, timestamp is the column name. Using the timestamp, I'm going to just filter out. So using the data frame, this is a normal AND operation. I'm going to check my data frames dot likes. If the likes are greater than the min likes, which is 10, right? And also timestamp should be uh, within this particular range. The start date and the end date is what I have provided here. And if it falls within this range, filter out only the data frames or only that particular sentence or the row, and then send it back, right? So I have this method created. Now I'm going to use this particular method in my main function here. So I'm going to copy that as well. So what I will do is, after cleaning, I want to now do that as well, right? So in addition to cleaning these, I also want to clean my data set. So basically I'm just filtering out those rows here. So I'm just calling the filter method using the same data frame and storing the same here, right? So I want to filter based on likes and stamps. Same way, if you have any custom scope, this is where the scope comes into picture. If you remember, we defined the scope of our project, right? In the first stage, in the project, we said that I want to have a time period, right? Or specific keywords or specific time. So in this case, I want to have specific likes which is greater than 10, and also specific time stamp, right, which is 1 month on April. So that's what I'm doing here. Now let's see how this particular data fares. We can compare the output of it. I can again save here and then configure and submit, right? All these can be automated using the Azure CLI commands or using the Azure SDK, right? So this is another way. If let's say this particular machine crashes, right, nothing happens because all these are stored in the designer, right? You can also export the whole designer configuration in the form of JSON file, and then you can store it in your repo as well, right? So that's another way of running these pipelines automatically from your repo to deploying it into your designer here, running it as a pipeline, and then running it whenever you want. And your data set can keep on changing, and you can keep on running these pipelines whenever you want it. Yeah. Now coming to the pipeline jobs, let me look at the job. I think this is running. Yeah, I think if you see here, one another thing I want to mention here is, there is a caching methodology which is very useful. For example, it did not reprocess all my stages again, right? It's just running only the Python script, right? Which is a good thing. Unless I change this particular component, it doesn't re-trigger or rerun, right? So only my Python script got re-executed because only I changed that. Now if you see here, I can see my output. Let's go and check the outputs. I can go and look at the word cloud. This word cloud should be slightly different, right? I mean, it might have filtered out more data. If you see here, I don't see much. Let me see the other one, right? So if you see here, there is a slight difference here comparatively, right? If I show this and this side by side, there is a slight difference though. That's what I think. Or my mouse is not well behaving. Yeah. So there are slight differences, but I'm saying this is how you can fine tune the data, right? Like I said, again, you can have custom methods. You can also have pre-built methods which are there, right? You can use those as well. Now coming to the next step in the process. Now what we have done is we have done the data collection, we have done the pre-processing, we have two more things left. We need to do feature extraction, right? If you remember, we are going to use either bag of words or df methodologies, right? I mean, these are different algorithms. Like I said here, there are multiple ways in which you can do feature extraction, right? I'll use both bag of I think I will use tf-idf, and then there is something called as ngram. So I'll show you how we can reuse some existing ones and the new ones. So let me go to the designer back. So I'm going to create a new step here. So after the Python execution step, I'm going to create a ngram component here. So there is an ngram extract which can help us here. And also I'm going to create one more Python script where I'm going to write the tf-idf script code for it, right? So let me go create a Python, and then I'll just, now for the, let's come for the, again, let me go here. Now we can link this particular execution Python output, which is the data set, into this particular stage as well, and this particular stage. So what I want to show you guys is I want to do two different feature extraction, and I want to show you how these two both are different, right? And you can do both of these at the same time, right? That's another advantage of this whole ml pipeline and ml designer, right? Now I can double click here. You can see something is missing. You can come here and configure the columns. So I want to configure the text column. So I'll just define the text column here. You can configure the vocabulary mode. I'm just going to say create new vocabulary. You can give the size of the ngram. I'm just going to say 1. There is a different weightage function. You can do binary weightage, tf, idf, or anything. I'm just going to say binary weight because I'm going to do tf, idf as a code, right? This is a predefined one. I'm going to show you by code, right? And then you can provide the minimum word length, maximum word length. A lot of customization can be done automatically, right? So I'm going to save this option. Done, right? I don't have to do any code for it, right? Now the same function if I have to do in a Python, right? Let me quickly grab that code for you, right? So I predefined, I have already written the code for it. So I'll just grab that for easy usage, and I'll explain it. Maybe I'll save it and then run and then explain. So once I save it, I can again go to the configure and submit, and this will just submit a new pipeline or a job. So the job is running. You can see this option here. Once you trigger the job, you can see that so pipeline job got submitted, and it will show you the link as well. Now I'm going to maximize and let's look at the code, right? So like I said earlier, yesterday we saw bag of words and tf-idf algorithm, how it can be leveraged for feature extraction. These libraries and methods are available in the scikit-learn library, so we can directly import it. So this is how you can import, right? So tf-idf vectorization is the method. You can directly import that from this feature extraction. Again, all these naming conventions looks familiar with to you because I'm using the same, right? If you look at it, feature extraction is the process. So again, we are using the same. So tf-idf vectorization is the same. I'm using the pandas library. Now again, since we are using the ml studio, we have to define the same method, azure ml underscore mail. Data frame 1 will be the input which we got here, right? So if you see, we got the input from the dataset 1 from the output of this particular Python script. So that's what we are getting here. So we will have the data frame data here. We had a cleaned tweets. That's where all the data is for us. Clean tweets is where all our data is present. We are going to convert that into a document, and we are going to provide that into the vector fit transformation. So this is exactly same code what Aditya showed yesterday as a part of the hands-on, right? Where we were vectorizing using the TF-IDF vectorization concept. I'm just giving maximum 100 features. I don't want to give too much. This itself is too much. 100 itself is too much. I will show you in a bit, right? And then I'm going to create a matrix. So what happens is, based on the sentence, we're going to create different words, and then we are going to map a matrix plot, right? That's what we saw yesterday, right? And we are going to do the same thing here, right? um, So this is where we are initializing, and then finally we are going to convert, right? So based on the vectorizers way of features, right, creating the feature names based on these words using the configuration here, it's going to come up with feature names, and we are going to map that into a data frame again. So we are going to map that into a table plot kind of a thing. I'll show that in a bit, and then we are going to display it. That's all we are going to do, right? It's a very simple thing. The same thing is done by the automated component here, which is the ngram feature. Again, we selected binary there. You can also select tf-idf here. Right now, let's go back to our pipeline. Let's see if it was successful. I didn't notice it. Yep, well, it's successful, and you can see that all these are green, right? Now if I double click this particular component, I can go to the outputs. Let me maximize. I'll show you the output for both of them, right? I can again look at the logs here using the stdlog.txt. I can also look at the output section here, the data outputs, right? If I click on this, I can look at the result of the vocabulary. I can see what vocabulary got created. So if you see here, this is the vocabulary for each and every word whatever was created, right? So there is a df score, and there is a idf score. So this is what is created as a part of the ngram algorithm, right? Again, all these are the different words. We said 100, so it just has 100. It shows the frequency, etc., etc., right? So that is what this automated component that did. There is also one more output. You can look at the direct data set. I will show you the data set. It takes longer to load. Let's wait for a few seconds. If possible, I will show you the data set. So you see here, this will show us our processed data for each of these. Again, if you see here, all these are plotted against each and every text which we had, right? All these are the text which we had. These are again plotted, and then there is a standard deviation provided for each of these rows, right, or the sentences. So you can see the different values getting populated for each of them, right? So that's what this plot shows up as well. But obviously result vocabulary is where we have the df and idf. Based on these parameters, again, you can convert this into a vector format and store it in your model, right? I don't think we have time to create the model, but this is how we progress to the next step, right? Now coming back to the Python code which we wrote. So what did our Python code do? Again, coming back to the outputs, let's go to the output data. Let me maximize, and you can see that there is again a result data set. I can maximize this again. It will take some time. If you remember, in the ngram we had a restriction on the count of the words characters, right? That's why it was very focused, and we had very little number of data set, right? But with the python code we had to do that manually. I didn't do a lot of code restriction there. That's why it is taking longer, because it's going to show a lot of columns for us, unlike how it was plotting in the ngram, right? Let's see how it shows up, right? I think it is done. So see here, we already had text, likes, and timestamps. We also had the processed pre-processed text column. We had the clean tweets. We had the tweet length. We were using these to plot them, and then now these are the new columns which got created as a part of the new python script, right? So if you see here, there is a standard deviation assigned to all these. I can, let me show you, there are multiple columns. I can just traverse here. You can see that there are different words for this particular word. For example, good, right? This particular sentence has a score of 0.3606. Now if you remember, we did this as a part of the yesterday's plot. I want to quickly visualize that for you so that you can understand this. So this is the one, right? So what we did in the data classifier using the bag of words, we split them into a feature. Same way we did that in the TF-IDF. So this is how we tokenize, right? So we are using the same method. If you remember, in the Python code, we use the TF-IDF vectorizer methodology. So it's using the same concept. We have a TF frequency, we have an IDF frequency, and finally we create a features with the words which are there, mapping to the score for each of these sentences, right? And that is what is happening in this particular program here, right? And that's the output of this particular Python component what we wrote, right? So this completes our end to I don't think it is end to end because we have to still create the model, right? We have created data collection, we have done pre-processing, we have done feature extraction, all these in a production grade system, right? Like how we are using a pipeline. Now, if I just shut this down, nothing will happen. I can come back and anytime create a new pipeline from this existing designer. I can export this and then I can reuse it, right? If you see here, I can also clone it. If let's say you want to use the existing one and then do something different, you can also clone from here, right? So again, if you are using your Azure subscription, do try out whatever we are showing. The code for whatever we just wrote, we will make it available today night or maybe tomorrow morning, right? In the same GitHub repository, we will create a day 6 and then we will upload that here. Do try out notebooks, do try out designer, upload your data set, right? And then try creating jobs yourself. Whatever I just showed you, you can try them out. There was one option where we were talking about Twitter APIs. Instead of uploading these data sets, you can use Twitter APIs. For that, we can go to the designer. There is a component called as web service, right? We can have a web input and a web output as well. So let me show you that. So if you see here, there is a web service input. You can use this as a data set and then you can configure it into your data sets, right? You can configure your Twitter APIs to pull this. Again, you can have an output. Once your data is processed, you can even call some data model or something. This is an output as well, right? So this is how you can configure. Again, you can use the documentation and then go through how you can configure the web service input, right? So I hope this particular hands-on was helpful. Let me just summarize just for the final sake, right? Because we covered a lot of things. I don't know how much of you, how of it is easily understandable, but I'll just cover again what we did, right? So as a part of our project, we had to do a data processing pipeline. We were having Twitter data set. We wanted to do data collection. As a part of data collection, we downloaded the data from Kaggle, right? Like I showed, this is the data set. It has tweet ID, username, text, retweet, likes, and timestamp. This particular data set, we are uploading it into a Azure storage, blob storage using the data assets here. And that data set, we are configuring it as a data option here. If you go to data, you can see all the data sets here. So I can see all the 3 data sets which I have uploaded. I have dragged and dropped here using the data collection. Now data collection is completed. We have to do now pre-processing of data. We have to clean up some data. So we are going to select some specific columns. So using this particular component, we are going to select only few columns. Using the remove duplicates component, we are going to remove duplicates for this particular text column. Duplicate rows, duplicate tweets will be deleted. As a part of pre-processing text, we are going to configure a lot of existingly available predefined algorithms which we can leverage. So I'm going to say like lemmatization as true, removing stop words as true, detecting sentences, normalizing them as a lowercase, removing numbers in them, removing special characters, duplicate characters, email addresses, everything can be removed from here, right? I'm going to configure and use that as an existing component. You can also provide custom stop words by plugging in to this particular pre-processed text. Your custom words can be plugged in with a data set, right? And that is given to a execute Python script. In this Python script, again, we are writing custom logic to do custom filtering. The reason why we wrote this is I want to filter by a number of likes greater than 10, and also I want to filter my data set only for a particular month, which is April, right? So I've written custom code for it, and also I have plotted this visually using some custom plots, right? There are also existing plots which we can use. We have written custom code here. As an improvisation or a refactoring to it, you can explore existing libraries or components to plug your plots into it, right? If you give the output in a specific format, all these gets plotted automatically, but we have handcrafted it and we have showed it, right? Now, the output of this particular Python script is now fed into the feature extraction process. That's the next process in the pipeline, right? We are giving it to the n-gram feature extraction, which is an existing component where we can define what size we want for the n-gram. I've just defined one, that's why it is faster. The weighted function you can provide as TF-IDF or a binary weight. I've given binary weight. You can have different word length configurations done here, right? Parallelly, I've written a Python code which we saw yesterday using the TF-IDF vectorizer library. So we are doing the same, and then we just saw the output getting created, right? So this is how you can progress any project which is machine learning based, and you want to create a data model, and you want to train your data sets. You want to clean up your data sets, pre-process them, and then create a feature extraction, and then create a data model out of it. Once you create a data model, there are again options available here within the ML Studio. where you can upload your data set here, right? For example, I tried creating a custom data set. So you can create your custom model and publish this model. You can register it here, and also finally you can publish this into your registry, right? So that anybody who wants to spin up their own data model, they can use it. This is how all these GPT models or any different data models gets created, right? So that's the end-to-end usage of how you can leverage Azure ML Studio to do production grade applications with the architecture of the data pipeline, right? I hope this was pretty much helpful. Again, for the final bit, Aditya, you want to cover the assignment for this for folks?
Yes, yes, yes,
Yeah,
yes. Um, Hey everyone, assignment for yesterday's session and today's session will be uploaded in some time, worst case by tomorrow morning, 8 o'clock. So please go and watch our GitHub repository, right? And assignment for yesterday would be related to NLP only. So yesterday we looked into how we categorize the data of a news article, right? But in as part of assignment, you will be going to understand the data set of IMDb, pre-process it, and analyze if the comments or the reviews is a positive or a negative statement, right? So that's something that you're going to do for yesterday's assignment. I'll be uploading it in some time. And for today's assignment, you will be using the Azure ML notebook and the designer. So I'll document it in a proper way, and I'll share that assignment mostly by tomorrow morning, right? So, and you have time till next Thursday, which is 26th of December. And today is our day 6, and we have two more sessions left. That's one on 27th, and the other one is on 28th. I'm super excited for the last two sessions. And the deadline for assignment uh, 2, assignment 3, and assignment 4 is also extended till 26th of December. Considering there are a lot of requests, people did not watch the live recording of the last session. They were still watching it. So considering the request, we have extended the timeline till 26. So please take time and complete the assignments for week 2 also, and now the new assignments for week 3. So if you have any questions, feel free to post that questions in the discussions forum. Yeah, I think that's all from my side, and hope you will have an amazing weekend. Thank you so much.
sure. Thank you, everyone. Yep.